This video provides an overview of the DB2 storage model. Let's start with pages and extents. A page is the smallest unit to manipulate data in DB2. There are 4 page sizes that DB2 supports: 4K, 8K, 16K, and 32K. You choose a page size when you create a table space or a buffer pool. The choice is made depending on the type of data, the size of your table based on the number of columns and sizes of each column, and the workload you want to perform. For example, if you create a table with one column of data type varchar 5000, then you will not be able to fit the table rows in a 4K page. Let's quickly test these by creating a buffer pool, a table space, and a table. The details of the statements I will use will be understood later on. So let's start connecting to the sample database. After issuing a DB2 connect to sample, I am successfully connected. Now I'm going to create a buffer pool with DB2 create buffer pool BP4K, that's the name of the buffer pool, with a size of 1000 pages, where each page has a size of 4K. Now I press enter, and I successfully create a buffer pool called BP4K. Now let's create a table space using the command db2 create table space. Let's call it tbls 4K. Then I have to specify the page size, and I'm going to use also 4K, managed by system, and this will be explained a little bit later in this lesson. I'm going to just put any directory here, and this directory, as I will explain there later, does not has to exist. So let me just call it cerase buffer pool BP4K. So what this statement is doing is creating a table space called tbls 4K with a page size of 4K, managed by system. We will explain that later on. Using cerase also we'll explain that later on. Buffer pool BP4K. So this table space has to be associated with this buffer pool with the name of BP4K, which was created earlier. So I press enter, and the command completes successfully as well. So now that we have created a table space with a page size of 4K, let's create a table called TBL1 with one column, and we are going to specify a data type of varchar with a size of 5000. Now we say that this table should be created in TBLS 4K, so in the table space TBLS 4K. So as mentioned before, this statement should fail. I press enter, and as expected, we are failing because the row length of the table exceeded the limit of 4K, or a little bit more, because there are some bytes used for internal information. Right, if we execute the same command again, but let's reduce these. Instead of 5000, let's use 4000 and press enter, then the statement completes successfully because it will fit in a 4K page. Even though a page is the minimum unit to manipulate data, DB2 doesn't work with individual pages at a time, but with extents. An extent is simply a number of pages. This is done for performance reasons, so that DB2 works with several pages at a time. The extent size is specified when you create a table space. Choosing the extent size can depend on the type of workload you will be performing. For example, for OLTP workloads, which stands for online transaction processing, like when you are, for example, accessing your bank accounts, trying to get the balance of your bank account, the access in this case will be random, and you'll be probably retrieving very small amount of data. So maybe the extent size that you should use for the table that that DBA has to use for storing the data in this scenario should be extent size that is not very large. In the figure, we have three disks, disk A, B, and C. We have two tables, table 1 and table 2. The figure shows different extents belonging to these two tables. Now, an extent can only have pages of one table. You cannot mix rows from different tables. DB2 will start writing into these three disks by writing extent 0 into disk A, then extent 1 into disk B, extent 2 into disk C, and then it will go back to disk A and write extent number 4 and so on. Extent number 7 and number 8 are for another table, which is table 2. Then we have table 1 again in extent number 9, and continuing to extent number 10 and number 11 and so on. So as you can see, DB2 is striping the extents across containers, which as we will explain later could be different things, but in this example are disks. So containers right now are disks, and they are being written in a round robin fashion. DB2 does this by default for performance reasons, because this way it spreads the data across different disks so that there are less problems in terms of I/O. So bottlenecks will be reduced for a given disk because DB2 is spreading information across different disks.